Alright, well, bunch of things to go through today, so I want to start with ODP 461, which just posted. I want to go through what that's asking you to do, and then look at a few details related to doing that, so passing strings and truncating them. And then I mostly want to talk about PA4 after that. So any questions up front? Alright, well let's start with the ODP then. So 461, you're writing a function named trim. And trim takes a single argument, which is a string, a character array, or a char star. It does not return any value, so it's declared to be void. So what trim does is it takes an argument, which is a string, and it removes the last character from that string. And it doesn't return it as a function value, it simply modifies this string in place. So strings, since they're pointers to characters, if we make a change to this string inside the function, then outside the function that change will be visible. So for example, if I call this with a string happy, when I'm done, the string that I passed should be just 4 letters, H-A-P-P. If I pass the string OK, it should come back just OKA. If I pass a string containing a single character, when I get back from the function, that string should have length 0, because that's the only character, that's the one that gets trimmed. If I call the function with an empty string to begin with, there is no last character, there's no characters, don't do anything to the string, just return immediately. Write your program, test it. When you think it works, link it with the test bed, and then go ahead and assess it. And there's one tricky detail about this, which is you have to be careful how you write your test program. And my recommendation is to do tests like this. Make yourself a character array, and then use string copy to take whatever string you want to work, happy, okay, x, etc. Copy that into temp, call your trim function, and then print out the string afterwards. And there's a reason I'm saying to do it like this instead of some other ways you might do it, and we'll see what that is in a minute. Well, let's talk.
Should trim function return 0 if the string is empty, or should it return be not empty?
It does not return anything. It's a void function, right? It's declared to be void. But the string that you pass in, if I just call this with quote quote, that string should just come back exactly the way it went in. It doesn't get changed at all. Now usually when we have a function, you know, like a mathematical function, we say y equals sine of x. We think of this as, you know, this goes in and this comes out. And that's our mathematical view of a function, right? And this would be, you know, something like if we wrote a double function called sine that takes a double argument. So we would read in a double as an argument, we would do some calculation, and then at some point we would have our answer, we would say return answer. And that's you know, what this is indicating. We're going to return something which is a double, and we could, you know, assign that somewhere. But sometimes with functions, we actually change the arguments in order to pass back a value. So we could, you know, we could make a function called square that we pass a number to, and when we come back from square, this number is twice what it was, or, you know, the square of what it was. So if we called square of 3, we would get back 9. So that's passing return values through the arguments themselves. And we usually don't do that in C because of this whole thing we call pass by value. But if we put an ampersand in front, right, so that we're passing a pointer to a number, we can change the number that that points to. And that's exactly what's happening when we're declaring our trim function to be a car star. We're passing a pointer to a character, which is also an array, which is also a string. So let's talk about how we would do this trim function, and then let's look at a specific example of passing a string to a function and making changes to it. And let's go ahead and send in the attendance note, because we're a few minutes in here. And let's think about trimming. So let's just suppose my input string is called input. So I'm a big believer in examples, right? If I want to figure out how to trim the last character off of my input string, the kind of way that I go about that myself is let's look at some example strings. So suppose my input is the string HAPPY. And remember, there's always a null terminator at the end. So index-wise, these characters are at starting from index 0, 1, 2, 3, 4, and 5. And if I want to take the last character off, that's the character Y here, all I gotta do is change this from a Y to a null terminator. If I can store a null terminator here in character at index 4, then anything that looks at my string is going to say, what is this string here? It's an H, an A, a P, and a P. That's it. That's the end of the string, because the next character is a null terminator. So that will effectively remove that last character and trim my string down to be one character shorter. So the trick now in our trim function is knowing where should we set that null terminator. Right? What index should we use? Well, if our string was happy, we want to use character 4. If our string was, go, then I want to set the string at index 1. So how do I know what index I should be putting that null terminator at?
Can use the string length function. This one.
So let's look at the string length. HAPPY, string length is 5. Go, string length is 2. String length tells you the number of characters before the null terminator. String length is 5, we want to truncate 4. String length is 2, we want to truncate character 1. So yeah, there's definitely a connection there. So I could do, len equals string length of input. And then I could do, index equals length minus 1. And this would be input bracket index. And that's really all you need to do, except for one other detail, which is see if input has length 0. Because if the input happens to have length 0 and length is 0, index is going to be minus 1. This is going to say input bracket minus 1, and it's going to be trying to change something in memory before the start of the array. And you definitely don't want to do that. That's a potential for a seg fault. So before I do this, you want to check to see if the input has length 0, and if it does, just return. You don't have to set anything in memory, you don't have to do anything, just say return. And it comes back without making any changes.
So would you say like maybe a less than or equal to 0 kind of a statement? Okay.
And string length will never be negative, but you can do less than or equal to 0, because if it was negative, same thing, you wouldn't want to make any changes. So yeah, if string length is less than or equal to 0, just return.
Okay.
All right. Other questions on that part of this? I want to talk about function passing next.
I just wrap my brain around trying to imagine a negative length string, an imaginary string.
Well, yeah, that would be interesting. Like, could you define a whole system of complex numbers related to strings with negative lengths or strings with imaginary lengths? I'm pretty sure you could, but it would take a lot of good music and some long walks. That's an interesting idea, though. And you can do things like that. You can actually, access, input bracket -1 or -5 or -200, just like you can. If this thing only has 6 places, I can still access input bracket 10, and the compiler will generate code that will dutifully do what that's asking the system to do, but it's not accessing, part of this array, it's accessing something else in memory. But we used to use negative subscripts in code to, monkey with the operating system to get to different memory locations before or after your local variables. But an actual negative length string is interesting. All right, so let's play a little bit with passing things to functions, because I don't think we've actually done a whole lot with building a string and passing it. And let me just pick on an example. Let's suppose that I have a string A, B, C, D, E, and I want to change this to the string A, B. Let's make a different trim function that always takes a string and chops it down to have length 2. All right, so if I feed in this string A, B, C, D, E, I want to get back this string A, B. And so if all we want to do is always trim it to length 2, that's not too sneaky a function to make. The trick is basically we want to write a null terminator in this third character. Right? So this is index 0, this is index 1, this is index 2. So for this, ODP 461A plus. Alright, this is not your ODP, this is a different version. The way we want to trim our string. Our code's pretty straightforward, right? Just take index 2 and set it to a null terminator. So let's play with this function, right? This non-ODP function, just to see what happens when we try to pass pointers to characters to a function and try to change those values and send them back. So I'm going to I'm just going to take this code from here. So I'm going to make a temporary array. I'm going to copy a string into it. And I'm going to put a couple of prints in here. I'm going to say initial string equals, and I'll print out the value of this string with a %s, and with our usual trick of putting angle brackets in here. And then I'll call my new trim function, and then I'll print out new string and show what the new string is. Alright, so what could our new trim function look like? Void new trim car star input. And I'm going to do something inherently dangerous, which is just blindly set element 2 to be a null terminator. And I'm saying that's inherently dangerous because how do I know that this array has at least 3 3 bytes associated with it. It's possible this is an array of length 1, and this is not part of the array, it's actually part of another variable that was declared after input. Right? So this is kind of an inherently dangerous thing, but I'm not worried about that because this is just junk code, and we're just trying to pass things around, get things back. So I'm making an array called temp, copying hello into it, printing it out, calling my new trim function, printing out the new string. If I start off with HELLO, the new string should just be HE, because I should have popped a null terminator into that third position. And I forgot my string function. Alright, so if I run this, not a big surprise. It works exactly like it should. So yes, you're right. It should just print HE. Alright, so this is good. This is how you can test your function, except in your case it would just take off the O. Here's where you can get into trouble. And you might think of doing this, and it looks like this should work, but this will actually get us into trouble. So I'm going to say car star temp equals hello. I'm going to initialize it in the declaration of this. This is saying temp's a pointer to a character. That makes it an array. This gives it an initial value. I'll print out the initial string. That will print correctly. I'll call my new trim, but something bad will happen in here, which is I'll get a seg fault. And if I GDB this, there's my temp, there's the initial string, hello. I'm going to step into my new trim function, and I'm going to execute this statement, and there's my seg fault. And the seg fault's happening right here. And it's a seg fault because when you declare something as a car star, it gets put into an area of memory that's not writable by us. It's a read-only string because it's basically like a constant. And so in my new trim function, when I try to change part of that string, the memory management system says, you don't have access to do that. I get a segmentation fault. Now you can get around this by doing something like this. And this should work. And I didn't know that worked until an hour ago. Somebody suggested it in the other section. So, but I've never written a statement like this before. So that's cool. So just be aware of that. And either way works, but the suggestion in the ODP was, when you want to load a value into your string, declare your string first and then use string copy to copy it. And so I could call my trim function multiple times, right? I could first copy this in, call trim, print the result. And then I could copy this in, call trim, print the result. Copy this in, call trim, print the result, and so on and so forth. And when you're testing functions, sometimes functions work great the first time and not so great the second time. And so if you write a main program that calls your function once and it seems to work, and then you change your program, run it, and that seems to work, right? That may all work great, but it may be if you had actually called the trim function twice in the same main program, you would have found an error. So it's nice to sort of have one main program that makes multiple calls to your function and tries different strings and tries them in different orders. Maybe the first time that I do this, that I try to trim an empty string, it works great, but maybe the next time I call trim after that, it's going to seg fault for some reason, right? So coming up with test cases is something you learn through experience. But exercise this as thoroughly as you can. And with these ODPs, it's nice to try to work to a place where the first time you do assess, you're always going to get 100%. And that happens not by writing perfect code the first time, but by getting really good at writing test cases. So that if you write code that's imperfect, which is inevitable, right? None of us write perfect code all the time. You discover it in your own test programs. And this is not only good, practice for outside of academia, but it's also really good practice in terms of understanding an assignment. To make sure that you know how to read the assignment prompt and you know how to identify when something's missing from the prompt. When you should say, hey Nick, you didn't tell us what to do in such and such a case, and that's going to be important in school and outside of school also. So if you're in a rush, write your code, assess it, cross your fingers. But if you got time, right, and energy, try to test these functions first. And then go ahead and do the assessment to confirm what you've already determined, which is my code is perfect, right? And then just run assess to get points for that. So that's something to think about. All right, so questions on that? So let me just make a unrelated comment on switches. This came up briefly yesterday in class. We were talking about switches, I think, in the earlier section, and we looked at sample switch statements, and we got into a discussion about whether this is more or less efficient than doing a bunch of ifs, like this, where we would just say, if it's 0, do this, if it's 1, do that, and so on. Otherwise, do this default thing. So, and I suggested looking at this in GDB and trying to get a feel for that. So I had a few minutes before class, so I went ahead and did that. So let's just really quickly take a look at a switch statement versus a bunch of if statements. So I want to start with this, which is, I'm initializing I to 3, and then I do a series of if statements, and when it turns out it finds I is equal to 3, it should print, high 6. And if we GDB that, we can start it. We can go into our assembly language view, and we can start stepping one instruction at a time. And without knowing anything about x86 assembly, we can still see what the flow is here, right? We can make a guess about what some of these instructions are. This is some kind of move, this is some kind of compare, this is a conditional jump. So it's going to do this move, it's going to do a comparison, it's going to try to do a conditional jump, but it's not going to do it, right? Well, it's going to skip down here. It's going to do another comparison. It's going to check a condition, it's going to jump. It's going to do another comparison, check a condition, it's going to jump. It's going to do another comparison, check a condition, and this time it's going to make a call. So this is those 4 if statements. If I equals 0, if I equals 1, if I equals 2, finally if I equals 3, and we found out I was equal to 3. So now it's going to make this call into something called puts. Puts is the beginning of printf. And if I say finish, it will go to the end of the put statement, and we can see it prints out, oh, I didn't print out anything. My output disappeared. But anyway, that's the flow, right? So it did a series of comparisons, and then it jumped down to the printf statement. Now if I do this on try 2, and I do my layout in assembly, and I step, it does a move, it does a comparison, it skips whatever a JA is. It does a move, it does some loads, it does a move, a load. It hasn't really done any conditional jumps yet, right? It's doing some kind of calculation. And now it's going to do a jump, and it's not a conditional jump. It's a jump Q, jump to a quad word, right? And that jump is the print statement that corresponds to I equals 3, right? Each of these calls to puts is a print statement. So this was the print statement for I is 2, I is 1. This is for I is 3, I is 4, I is 5, and so on. So it'll go ahead and do that call to puts, and if I let it finish out of there, it jumps down to the end of my program and it exits main. So without really understanding the assembly language, what we can see from just the program flow is that when we get to the switch statement, there's not a series of ifs that take place. There's some sort of calculation performed, and then they jump down to this line of code. And that's why switches can be more efficient than doing if-thens. Because, based on the value of I, we can figure out ahead of time what the address is for each of these statements. We can store those in something like an array and then use I as an index into that array and say, hey, I is 3, jump to this location. And it jumps down right away. So that's just another example of the kinds of things you can do with GDB, the kinds of analysis you can get into, and so on. All right, not on the exam, but that'll be good stuff in 222. All right, PA4, the long-awaited. So, programming assignment 4, you're going to basically make an appointment calendar. And I got a lot to say about this, but not as far as requirements, more about kind of the setup of the assignment and some things to keep in mind. So highlights to know about. First of all, this is if you choose a group project. You can work in groups of up to 4 people. If you want to work alone, you can work alone. If you want to work in a group with one other person, you can do that. It's totally up to you. I'm not going to assign groups. I'm not going to require groups. So you can choose amongst yourselves who, if anyone, you want to work with. And how you're going to do this as a group. Are you all going to work on it together? Are you going to break it off into pieces? That kind of thing. It's going to be a bash program, and it's going to be GUI based. So we're going to talk about a command called dialog that'll let you make graphical interfaces. The biggest thing to know about this project, though, is that you have a huge amount of flexibility in what you do and how you do it. And the previous assignments and the ODPs are so nitpicky, right? I'm telling you, you have to do this, and you have to call this function that, and it's got to be in a file with this name, right? So this one, we're just kind of opening it up wide. And you get to do kind of what you want, however you want, as long as you satisfy a few essential requirements. So the requirements are your program has to run on the Linux server, has to use a dialog command to implement graphical interfaces, GUIs, and you need to be able to do 3 things. You need to be able to make an appointment on a given date, delete an appointment, and look at upcoming appointments. So you'll run your script and something, will pop up and say, what would you like to do? And you can say, I want to make an appointment. And maybe it'll show you a calendar and you can click the date of the appointment, and then it'll say, what's the appointment? You can type in a description and it'll record it somehow. Or you could say, I want to delete an appointment, and maybe it'll let you pick a date and show you the appointments on that date, and you can choose which one to delete. Or look at all the upcoming appointments. So see what today's date is, find all the appointments today or later, print out a list of them in a GUI box. All right, so you got to be able to do at least these 3 things. And I want this to happen through the GUIs. I don't want to have to go into the command line and type information, type in commands, things like that. It should all be point and click. All right. And your calendar should be saved from run to run. So if I go into this and I run your program and I make a bunch of appointments and then I exit, if I run your program again, I should still see those appointments. So you're going to want to save this information somewhere on the hard drive. And you can do this a number of different ways, but you don't need to make a database and all that kind of stuff. You can just have a plain text file. And for example, you could just have a set of lines separated by pipes containing a date, a time if you have a time, and a description of the appointment. And if multiple people are going to be working on this and you want to share your calendars, you can create a file that you all have access to. I've made a directory under /temp called calendars. You're welcome to create a subdirectory underneath that just for use by your group for storing calendars, and you can put whatever files you want in there. So that's an option. You don't have to develop this on the Linux server. If you have a way to do this on your own machine, you're welcome to do that, but make sure it works on the Linux server before you submit it as done. Alright, so it's got to do those three things, but then you also have to implement additional features, and you need to implement 3 additional features. And here's some suggestions for features you could implement, but if you have some other feature in mind, let me know, and we can talk about it, and I'll say, yeah, go for that, or I'll say, you know, how about doing something like this? So some ideas for additional features: being able to edit appointments. Right, we can enter and we can delete, so we could always, you know, change an appointment by deleting it and making a new one. But you could add an edit option, so you can go in and change the description or change the date. Being able to add times as well as dates, that counts as an additional feature. Being able to add an end time, so you have a duration for your appointments, that's a possible feature. Checking for conflicts, right? There's no requirement that if I schedule 5 things on the same day, that's totally okay. But you could check for conflicts. You could view all the appointments for a given date instead of just all future appointments. You could view appointments for a date range, specify starting and ending date, and show everything that's scheduled between those 2 dates. You could add a reminder feature, so when you start your program, it looks for any appointments coming up today and prints out, you know, in a box, hey, here's what you have coming up today. Right, so all these useful things that calendar programs do for us. You could try adding an alarm feature. This one takes a little more sophistication on the Unix side itself, but you could write something that, you know, sends you a message on the Unix server 5 minutes before an appointment is due. You could try to import from other utilities like Google Calendar, ingest one of their iCal files. That one's fairly open-ended and probably complex. And you know, if you got an idea, talk to me about it, and you know, you can choose your own features. But requirement, you got to do these 3 things, and then you got to implement 3 additional features of your choosing. All right, groups. You can have groups of up to 4 people, including yourself. If you want to work in a group, you got to let me know, and I'm going to ask you to let me know in the following way. Send me an email, nmacias@clark.edu. Make the subject CSE224 PA4 group. And then in the body of that message, just list the full canvas name of all the people in your group, including yourself. Okay? This is not getting processed automatically. I'm going to process this myself. But the closer you stick to this format, the less chance of confusion. If you send me a message with a different subject and it says, you know, I'm thinking of working with Tom and Sally, but I don't know if Tom's going to be available, so I might not work with him, right? Then, you know, there's going to be confusion. So the closer you stick to this, the better things will be. If you're going to work alone, that's totally fine. If I don't get an email from you by November 10th, I'll assume you're working alone. If you want to send me a message and say, you know, just your name in there to say you're working alone, that's fine too. But anybody who doesn't present, you know, as working in a group, I'll just assume you're solo. And then the submission, this is a rare Monday deadline, so this will be due Monday the 15th of November, not 15th of now, 15th of November, 8 a.m. So you've got this coming weekend, but you also have the following weekend to work on this. Because group stuff, you know, sorry?
As a thank you for that.
Yeah. Group stuff can be a little more complex logistically, so take the extra weekend if you need it. And to submit, I've got access to everybody's CSE224 GitLab repository. Um, and if you're collaborating with other people and you're doing this through Git, that's fine. You can do that. You can set that up. You can give access and so on. But I'm going to ask that the final submission for the group goes in a directory called PA4 final, right, underneath CSE224 in the usual repo. But it's easiest if only one person from your group creates that directory. And so at the deadline Monday morning, I'll download all the repos, and anything that's in a directory called PA4 final, I'll assume that's a submission. If it turns out two people from your group have a PA4 final directory, right, I'll grade the first one I encounter. So make sure you coordinate among the people in your group who's going to upload this to their repo. All right, and then you get to demonstrate your code to the class. To me mainly, but also to the class. And the idea here is that you're creating this, you're designing it, you know how to use it, right? I'm not going to ask you to write a user manual, so you can demonstrate to the class how your program works. And so you should show the basic behavior, make some appointments, load them into the program, show that you can see them, delete one or two of them, exit the program, come back in, see that the appointments are still there, and then demonstrate whatever the additional features were that you chose to implement. And the bulk of the grading will be based on how the program behaves when you demonstrate it. I'll also go in, I'll look at the code and so on and so forth, but this is primarily graded based on does the program work or not. So your demonstration is really just showing me that it works, right? And it's super low key. You're not graded on how polished your presentation is or having PowerPoint slides or anything like that. It's really just demonstrating your program. All right. My suggestion for rehearsing your presentation ahead of time though is if you've got 4 people in the group and I say, okay, group 7, let's go ahead and see your project. That's not the time to say, well, wait, who's going to present? Well, I don't have the latest copy. So and so does. But his Zoom isn't working, and so just figure that out ahead of time. And after Wednesday, when I know what the groups are, I'll go ahead and I'll use a randomizer to order those groups, and I'll post a presentation schedule. And we'll just go through in order with each group demonstrating their program. So don't get worked up about this. It's not high stress or anything. And you only need one person from the group to do the demonstration. If you want to take turns, tag team, I'll show this part, you can show that part, I'll go through the code, that's fine too. But if you want just one person or just a few people to do it, that's totally okay. So just figure that out amongst yourselves. Let me know if you have questions. All right, grading. So you need 4 things to get any points at all. The program has to be submitted by the deadline, has to run on the Linux server, has to use the dialog command, and has to be presented to the class during the scheduled presentation time. So you need those things to get any grade. And then, assuming that you present it, the grade is a really straightforward rubric. So those 3 mandatory requirements are 20 points each. Can you make an appointment? Can you delete an appointment? Can you look at upcoming appointments? And if it saves appointments from run to run, that's another 10 points. And then 3 optional features, 10 points each. So there's your 100 points. And I know some people see the deadline as being, over a week away and are thinking like, good, I don't have to worry about this till next week, right? Do the time management you have to do, but my suggestion is try to start this early. Definitely try to nail down a group as soon as possible, because some people in your group might have more time this week than next week, and maybe they can do some of the initial design, or some of the initial framework. And you might have more time next week, so you can work on, some of the extra features that are going to get added in, and so on. So start early if you can, and try to have fun with this. Okay, this is a lot of creative freedom on your part. What it's going to look like, how it's going to run, what the user interactions will be. You get to decide all of that. So hopefully you can have some fun with it. Alright, so I want to talk about the dialog command, but any questions first? Alright, so let's look at dialog. Dialog is a Unix command. It's installed on the Linux server. It's good for creating GUIs, but they're old school, like 1980s style GUIs. So they will work with just, a plain text terminal. If you use PuTTY, they come out looking funny sometimes. Let me know. I'll post something on how to fix up PuTTY. But let's just take a look at some examples of this. And tomorrow we'll go through this in more detail. And look at more specifics. But this is one of these things where I'll give you the basics to get you started, and there's manual pages on this, and it's a whole lot more fun to just play with this command and see what it can do than to read a book on it or read a manual page or listen to me talk about it. But dialog is built in. You can install it on your own VirtualBox, your own Linux machine if it's not there, but it's got a gazillion options, right? It's got all these common options, box options, and so on and so forth. And I'm just going to go through a few of these. So the first thing we can do is, it's always dialog is the name of command. -- we can put in what kind of thing we want to create. So I can say -- info box, and I can say this is an info box, and we end it. I don't care about typos, but I guess I do. We ended with 0, 0 usually, which are the dimensions of the box that we're creating. So I'm going to do dialog info box text message 0, 0, and there's an info box. Magic, right? And it's just a bunch of ASCII characters that are creating, the blue color and making this box and the drop shadow and so on and so forth. I can do a message box, and a message box is dialog message box title 0, 0. It's like an info box, but it waits for the user to click the OK button. So it shows me the message, and then it waits for me to click. And this is pre-mouse capable, so I can just hit a space bar to signify a click, or I can just hit an enter key to signify a click. And I can use the tab key to move from one option to another if I don't have a mouse, and so on and so forth. So this is all keyboard friendly. We can add titles to most of these boxes. So we can say -- title. This is the title, and there's a title on my box. And so there's two chunks to the documentation. The first are the common options you can put on different boxes, things like title and timeouts and things like that, colors and such. And then there's all the different boxes that you can actually specify. So the info box, the message box, and so on and so forth. We can do a calendar. So if I say dialog -- calendar, choose a date, or some message, choose a dat, or some message, and then 0, 0, and then I can put in a default date if I want. So what's today's date? 4th of November, 4th November 2021. So this pops up a calendar, and it's highlighting the current date by default, but I can click on here. I can tab over to here and arrow key to different months, different years, and I can go to different dates and so on. And when I'm done, I can click the OK button, and there are ways we can capture that date that this thing presents, but it knows that I just did. January 21st, 2025. So this is obviously useful for an appointment program, right? And we
Can we use this calendar as part of our appointment calendar?
absolutely. Yep. Yeah, you don't have to do a whole lot of work for creating the GUIs. You should just use the dialog command and let it do the heavy lifting there. And we'll talk tomorrow how to capture the output from this, but we can write a bash statement that looks like this, but actually takes the calendar date that you've chosen and stores it into a bash variable. And we've just got to type some weird things in here, but it's pretty straightforward to do if we have more than 3 minutes left. So yeah, you can use this to do everything. So when you want to have the user type something in, you can pop up a box and have them type in it. We can do things like dialog yes no. And this will pop up a box where the person can select yes or no. And so if they say yes, we can detect that after the dialog command comes back by checking the value of this special status variable $question mark. If they say no, and we check $question mark, it'll be a 1. If they say yes, $question mark will be a 0. And we can pop other buttons up on here, and see what button they pressed and so on and so forth. All right, so we'll go into more examples of this tomorrow. We'll go a little more carefully, and maybe I'll post a list of sample commands. But we can use all the power of Linux that we've learned, and for example, make an info box containing talking cow. Because we know how to use back quotes, and if I say back quote some command, the result of that command replaces the back quoted expression. So I just said dialog info box quote all of this stuff, so it pops up in an info box. Alright, so we'll dig into that further tomorrow. Somebody just asked in chat, how come 461 gets 10 out of 10, but when you run it in the command line, I get a seg fault? Try running it with a command line argument. That'll get rid of the seg fault, but it'll give you an Easter egg. So some of these ODPs I set up so that they only work when you run them through the assess command. And that's the direction I'm moving in. So I just wrote this ODP right before class started. So I tossed that feature in. So the function that you create only works through assess. But you got 10 out of 10, so that's the key. All right, any parting questions? Tomorrow we'll pretty much play with the dialog command and just dig further into that.
I had a quick question on the ODP.
Sure.
Being that our functions may be void, how are we returning the trimmed string?
So you return it in the argument itself. Right. So this is what we were doing here. So you pass an argument in, which is a char star. If you make changes to that argument, those changes are visible when you come back from the function.
Oh, okay.
So it's returning.
You don't have to return a value. It's going to automatically assign it because you're assigning it.
Right. Yeah.
Baffled me a little bit.
Yeah. So it's returning through the argument itself.
Okay.
All right. So let's do one more attendance ping on the way out. We did one in the beginning, but get me now. You're good to go. And yeah, that should do us. So have a good afternoon. I will see you tomorrow.
Goodbye.
See ya.